How well do you actually know our home galaxy, the Milky Way? A question that led a team of researchers from Villanova University on a 4-year quest, funded by NASA, to map out the heart of our galaxy. Their findings? A never-before-seen view of the Milky Way's central engine, the powerhouse that fuels the life cycle of our galaxy. This central engine is a bustling hub of magnetic fields and cold dust structures. Picture it as a cosmic construction site, where dust forms the building blocks of stars, planets, and eventually life as we know it. The magnetic fields? They're the architects, directing the dust and influencing the design of our galaxy. But why is this important? Well, understanding how these magnetic fields interact with dust gives us a clearer picture of the Milky Way. It helps us comprehend our place in this grand cosmic scheme, and even offers us glimpses of how similar processes might unfold in the central engines of other galaxies. Until now, the relationship between dust and magnetic fields in the formation and evolution of stars and galaxies has been somewhat overlooked, especially in our own galaxy. The Milky Way, after all, is filled with a lot of dust. This dust, born from the death and explosion of stars, is crucial for our galaxy's life cycle. So the team, led by Professor David Chuss, a physicist at Villanova University, set out to study the light emitted from these cool dust grains. The result? A complex snapshot of the Milky Way's magnetic fields and the intricate dance they perform with the dust at the heart of our galaxy. By exploring this dusty central zone, they've begun to unravel the mysteries of our home galaxy and understand how this cool dust aligns with the magnetic fields at the heart of the Milky Way. This alignment also reveals the orientation of these magnetic fields, a characteristic referred to as their polarization. A clearer picture of dust and magnetic interactions builds a better understanding of the Milky Way and our place within it. The journey to understanding our cosmic home continues, and with each new discovery, we inch closer to comprehending the intricate workings of the universe. Deep within the Milky Way lies a region known as the Central Molecular Zone, packed with an estimated 60 million solar masses of dust. This dust, far from being just space filler, forms the building blocks of stars, planets, and life as we know it. It's a vast reservoir with a temperature of around -432.7 degrees Fahrenheit. That's just a few degrees above absolute zero, the theoretical temperature at which all atomic movement would cease. Also located at the heart of the Milky Way is hotter gas that has been stripped of its electrons, or ionized, existing in a state of matter called plasma. This plasma traces magnetic fields in the hot ionized component of the center of the Milky Way. But why focus on this dust and plasma? Well, they are key to understanding our galaxy's life cycle. When stars die and explode, they disperse heavy elements that form cool dust grains. This dust, in turn, forms new stars, continuing the cycle of stellar birth and death. The magnetic fields, on the other hand, play a crucial role in shaping this dust. Scientists believe that these magnetic fields might be guiding the dust, aligning it in certain ways. This alignment, referred to as polarization, could provide insights into how these magnetic fields are oriented. However, the relationship between this cool dust and the magnetic fields has been somewhat overlooked, especially within our own galaxy. That's where a team led by Villanova University researchers comes in. As part of a NASA-funded project, they've obtained a never-before-seen view of this central engine at the heart of our galaxy. Their new map reveals the interaction between magnetic fields and the cold dust structures that dwell in the heart of the Milky Way. This clearer picture of dust and magnetic interactions will help us better understand our place within the Milky Way. Understanding how stars and galaxies form and evolve is a vital part of the origin story of life. Also located at the heart of our galaxy is hotter gas that has been stripped of its electrons, or ionized, and exists as a state of matter called plasma. Now imagine this plasma as a kind of cosmic soup, a hot, charged mixture of particles swirling in the heart of the Milky Way. It's not just aimlessly floating around though. Oh no, it's guided and shaped by something unseen yet incredibly influential: magnetic fields. Magnetic fields are like invisible threads running through the cosmos. They're created by moving electric charges, and they exert forces on other moving charges. It's a bit like an invisible puppet master, pulling the strings of the ionized plasma in our galaxy's core. But how do we know they're there, these magnetic fields? Well, we can't see them directly. Instead, we look for their effects on the plasma. You see, when this plasma is subjected to a magnetic field, it becomes polarized. Polarization might sound like a complex term, but think of it as the plasma choosing a side. It aligns itself in a specific direction in response to the magnetic field. And by studying this polarization, we can get a sense of the magnetic field's orientation. It's a bit like using a compass to find your way. The compass needle aligns with the Earth's magnetic field, showing you which way is north. So, the team led by Villanova University researchers delved into this cosmic soup, seeking to understand the relationship between this ionized plasma and the magnetic fields. They wanted to know how the plasma's polarization could reveal the orientation of these magnetic fields. Why is this important? Well, understanding the role of magnetic fields in the heart of our galaxy helps us grasp how stars and galaxies form and evolve. It's a crucial piece of the puzzle in our understanding of the life cycle of our galaxy, and indeed, the universe itself. The team sought to understand how this cool dust aligns with the magnetic fields at the heart of the Milky Way. To investigate this dusty central zone, the research team embarked on the Far Infrared Polarimetric Large Area (CMZ) Exploration or FIREPLACE Project. FIREPLACE, a project fueled by curiosity and the desire to understand our cosmic neighborhood, took on the challenge of investigating the heart of our home galaxy, the Milky Way. This project, funded by NASA, used the Stratospheric Observatory for Infrared Astronomy, also known as SOFIA, to delve into the mysteries of the central engine of the Milky Way. Now, SOFIA is no ordinary observatory. Circumnavigating the globe at an altitude of 45,000 feet aboard a Boeing 747 plane, it is a telescope that quite literally soars above the clouds. This lofty position allows SOFIA to observe infrared light from cosmic dust grains, which would otherwise be obscured by Earth's atmosphere. The main objective of the FIREPLACE project was to create an infrared map of the central molecular zone of the Milky Way. This map was no simple feat. It took a dedicated team and 4 years of hard work to assemble it. But the result was nothing short of extraordinary. The map revealed the relationship between the magnetic fields at the heart of our galaxy and the cold dust structures that dwell there. This dust, remember, forms the building blocks of stars, planets, and in essence, life as we know it. The central engine of the Milky Way drives this process, and by understanding it, we get a clearer picture of the Milky Way and our place within it. But the implications of this project go beyond our galaxy. The team's findings offer glimpses into how dust and magnetic fields interact in the central engines of other galaxies, broadening our understanding of the universe. This project is a testament to human ingenuity and our insatiable desire to understand the cosmos. It's a step forward in the quest to unravel the mysteries of the universe and our place within it. After all, the more we understand about the engine that drives our galaxy, the more we understand about the cosmic neighborhood we call home. So, how well do we know our home galaxy, the Milky Way? A question that has sparked a 4-year-long exploration into the heart of our galaxy, leading to insights that have reshaped our understanding of the Milky Way and beyond. This new map, a masterpiece of cosmic cartography, reveals the intricate dance between magnetic fields and cold dust structures in the central engine of our galaxy. It has shed light on the life cycle of our galaxy, the birth and death of stars, and the creation of planets and life itself. But the revelations aren't confined to our cosmic neighborhood alone. This research also offers glimpses into the central engines of other galaxies, widening our understanding of the universe. It's a significant step towards understanding the origins of life and the evolution of galaxies. A better understanding of our galaxy not only satisfies our curiosity but also brings us closer to comprehending our place in the grand scheme of the universe.